Helm is often referred to as the package manager for Kubernetes, and there's a good reason behind it. It allows you to simplify all the complexities of packaging a Kubernetes application by encompassing all the resources required to deploy your application, be it deployments, stateful sets, services, and encompass all of that inside a Helm chart to make your applications easily distributable on different Kubernetes clusters. In this video, we are going to see how you can take your Helm packaged applications and spin cloud-native development environments for them with the help of Okteto. So let's get started. Okteto empowers platform engineers to streamline and automate the modern development experience. It gives platform engineers the ability to create self-serviced environments for developers which are exactly like production. And when we say exactly like production, this is where we mean that we will leverage the existing Helm charts we use to deploy our applications to production and use them to spin up these dev environments. The best part is that since Okteto will automate all of this, developers don't have to do anything but click a single button to deploy their application and spin up their entire dev environment. This accomplishes two things. One, it ensures that developers are developing in a realistic environment since you're leveraging the same Helm charts you use to deploy to production. And secondly, it ensures that developers do not have to spend any cognitive load on creating this dev environment, on dealing with Kubernetes, because Okteto will take care of all of that by automating these processes. Let's first look at the application we'll be working with. It is a to-do list app with 3 microservices. It has a React frontend, which is in the client directory, a Node.js Express server, and a Postgres database. You can find the code for this application in this repo. I have the application cloned locally, and let us explore the application a bit and see how things are structured. I have my Helm charts for each of the service inside a chart folder, which is inside the folder for the service, and that consists of the chart to deploy that particular service. So this is the chart which deploys the front-end service, and I have the deployment, a service, and an ingress. I also have a values.yaml which I'm using to provide configurable values for different fields, in this case the replica count for the client deployment. And similarly, I have a chart to deploy the server and a chart to deploy the database. Before we begin writing the Okteto manifest for our application, which will allow us to spin development environments on Okteto, we need to ensure something in our Helm chart. If you look closely, you'll see that our image name is hard-coded right now. This presents a problem because this means whenever developers spin up a dev environment, they'll only be able to use this particular image. Now, this particular image might be a week old or a month old, depending on when it was pushed by the DevOps team on the repository you are using. What we want to do is allow this image to be configurable just like the replicas above. So we're going to use Helm for that and add values.image here, and that will allow us to configure this image name when we install the Helm chart by running helm install. Since we have done that, we'll also need to add, let's just provide a default value. So go to my values.yaml and I'll provide the image a default value, and this is in case we don't provide anything during runtime, and this is the client, so I know that the image is, and we'll do something similar for the server as well. The reason we did this because now whenever we spin up a dev environment, this will give us the flexibility of passing a particular container image, be it a dev, prod, or a particular branch in your repository, instead of having a hard-coded fixed image which was pushed who knows when. With this done, let's begin writing our Okteto manifest, and soon this will start to make more sense. Create an okteto.yaml on the root of your repository. In case you're not familiar with how the Okteto manifest works, it is a fairly simple manifest which allows you to define how your containers get built for your dev environments, how your dev environments get deployed, and how your dev containers behave. It has 3 sections called build, deploy, and dev. So let's add first those 3 keys. Now let's populate each of these sections step by step. The build section contains instructions for Okteto on how to build your application images. This allows Okteto to build the images from the latest code in a particular branch or a particular commit you want to use. The way to do this is by specifying the name of the service, let's say client in this case, and telling Okteto where the Docker file for that lives. For our case, since it lives inside the client folder, we can just add the folder name. And we'll do something similar for the server service as well. And that's it. If you want to define the exact specific location of your Docker file, you can also use the Docker file key, but that is not needed in this case because our Docker file just lives at the root of the folder. The deploy section is where we give instructions to Okteto on how to deploy our dev environment, and this is where we leverage the Helm charts we have for each of our microservices. The benefit of this, like I said earlier, is that since you're using the same Helm charts you use to deploy to production, your dev environment gets spin up in a similar manner, ensuring that the gap between dev and prod is as minimal as possible. So let us add the instructions to deploy each of our services. You'll see that I added the name, which would just let us know in the UI what step the deploy phase is at, and the command, which is Helm upgrade with the install flag. So what this will do is if you want to redeploy your environment, it'll just check if there is a different version and then upgrade it, or if it has not been installed, then the install flag would ensure that it installs the particular chart which is inside db/chart. So let's do this for the client and the server service as well, and that's where you'll notice that we'll do something differently for the Node.js backend we have. Now for our DB, we are using the Postgres image directly from the Docker Hub repository where Postgres puts the latest images. But if you notice that for our server, we are actually building the image. So we want to reference the image which was built by Okteto in the build step and pass that to our deployment. And that is why we, made our deployment configurable. So you see that we are now able to pass a particular value for the image, and we want to pass the value which we built in the build phase. Okteto allows you to refer to the image you built in the build phase using a special environment variable called Okteto build, then the name of the service and the name image. So let's do exactly that here and use the image which we built in the previous step. And this is it. That's how easy it was to reference the image you built for your installing this particular service. Now let's do something similar for our React front end. And this completes our deploy section. At this point, I would encourage you to try out your application, see if the build and deploy commands are working, and let's do exactly that by going to our terminal and running Okteto deploy. So you see that Okteto is done deploying our application, and we can go back to our Okteto dashboard and see that our application has indeed been deployed, and we have endpoints where we can access our application. Let's test out the application by typing a to-do, and we can see that it is working. But right now there's no way for a developer to actually start developing this application because we haven't configured the dev section. So let's go back to VS Code and do exactly that. Before we begin writing the dev section, you need to understand what happens when a developer runs Okteto up to begin their development session. Right now, our application containers are being run in the Kubernetes cluster based on the commands we specified in the deploy section. But when a developer does Okteto up for a particular service, what Okteto will do is it will replace the running container with a dev container. Now what's special about this dev container is that it will synchronize the files on the local machine with the code which is there in the container. So what this will ensure is that as soon as you hit save, the code changes you make get transferred to the Kubernetes cluster, and you're able to see the result of your applications live instantaneously. Now, this is the exact same experience as if you were developing locally, except that all the workloads have been migrated to the cloud. So none of the containers are running on your local machine, and you have so many more free resources on your local desktop. Okteto also gives us a terminal inside that dev container, and the dev section is where we can, start to define the behavior of Okteto app and the session we get inside that dev container. Now, the dev section comes with a lot of options to configure how your dev containers behave, but we'll keep things simple for just getting started and write a section for our server and client microservices. So you'll see that I wrote the name of the service and then the command I want to be running by default in the terminal I get inside that dev container. Now, you could have replaced this command with npm start if you wanted the server running as soon as someone does Okteto app, but I wanted to show you how things behave, so I just did bash so that you can get a better feel of what happens. And secondly, the sync key is where you tell Okteto what folders to synchronize from your local machine to inside that container. So our code for the server is living inside the server folder, and I synchronized it with the app directory because that's what the working directory for that particular container is. Let's do something similar for our client service as well. Awesome. With that, we are now ready to go. So you see that our application is now actually deployed because we ran Okteto deploy. Let's get a dev container to the front end service so that we can actually change things on the front end. The way to do that is just by running Okteto app, and what Okteto will do now is list all the microservices which are developable. So in this case, I'll choose the client. And by the way, in case you're wondering why we are not seeing the database service, it's because the database service is not something you can actually develop. It's just a Postgres container which is running a Postgres database. So that is in the context of this particular application. If your application has some configuration which allows you to develop the Postgres database or change anything in the database as well, then you can add that key here, just like we have done for client and server in the build section, in the dev section, and deploy section likewise. So you'll see that Okteto has now given us a terminal inside the dev container, which is now running in place of the original container which was running for the front-end service. And since the container has been swapped, it would make sense that a front-end service is no longer working. So we hit refresh and we see that like the service is like not listening, and that makes sense. So we can start the service by running npm start. And now our front-end service should be back again. So if we go back and hit refresh, we'll see that our service is up and running. And this is what I was saying earlier. Instead, if you want to avoid this step for developers, you can just have the npm start instead of the bash command. But I put bash just so I could show you how the terminal inside the dev container behaves. And now we can actually start developing our application. So let's change the name of the application to something which is a bit more pronounceable. So I'll search for this and I see that the name of the application is here, and I'll go back and change it to to-do list, hit save. And this is the experience you as a platform engineer are able to enable for the developers on your team, right? Once you have configured this, all they need to do is deploy their application by Okteto deploy or from the UI by launching a dev environment, and then they can simply run Okteto up and get started with development. So if we go back, hit refresh, you'll see that React detected our changes and we see our updated application here. The best part is that developers can do this for each of the services they want, and once they have the entire application up and running, they can just choose which service they want to work on, and they can work on multiple services simultaneously. So this ensures that, once you have done this configuration for developers, they don't have to do anything in terms of deploying the entire application, in terms of setting up a realistic dev environment. They don't have to deal with Kubernetes, and they can get straight away to writing code. So this was it. This is how simple it is to take your Helm applications and get started with developing on Okteto. This video has a blog accompanying which dives deep into more of the concepts we discussed and tells you the value you get out of this approach. If you would like to read that blog, you'll find the link for that in the description of this video. You'll also find the link to the app we used in the video description. If you found this video useful, subscribe to our YouTube channel for more such content. You can also sign up for our newsletter on Okteto.com and get an email whenever we publish a video or a blog. If you liked Okteto and are convinced on the idea of enabling a modern development experience for the developers on your team, go to our website Okteto.com and sign up for our free 30-day trial. I'll see you in the next video, and until then, happy hacking!